So if we look at a worked example using this idea of conservation of momentum, then we've got a car here of mass 1,000 kilograms moving at 9 meters per second, and it's going to collide and stick to another car 1,200 kilograms 5 meters per second. In this example, we'll choose the positive direction to be to the right, and then we can start to list what we know. So before the collision, the momentum of car A is 1,000 times 9,000 kilogram meters per second. But for B, we've got to take account of the opposite direction of the velocity, so it's 1,200 times minus 5, which is minus 6,000. So the vector sum of these two, 9,000 minus 6,000, gives you a total momentum before the collision of 3,000. If we now look at what's happening after the collision, then the cars are stuck together, so we now have a total mass of 2,200 kilograms, moving at some unknown velocity v. That's what we're trying to work out. So after the collision, the total momentum is 2,200 times v, and because we've got this concept of conservation of momentum, then we write our statement of conservation of momentum. Momentum is conserved during the collision. And then we take the momentum from the left-hand side and set it equal to the momentum from the right-hand side. The momentum before equal to the momentum after. And then we can rearrange to get our answer for V. And then just moving on towards the end of the example, state clearly our direction of the velocity. So in this case, positive means to the right.